Hi guys, how are you? I hope you will be fine. So guys, let's start. My today topic is electrolytic cells. In an electrolytic cell, electric current is used to drive a non-spontaneous reaction. When a non-spontaneous reaction takes place at the expense of electrical energy, the process is called electrolysis. During this non-spontaneous reaction, the substances are deposited at respective electrodes and electrolyte is decomposed. Examples of electrolytic cell are Down cell and Nelson cell, etc. Look at the arrangement as shown in figure 10.1. It represents an electrolytic cell. Two electrodes are dipped in the solution of an electrolyte. The electrolyte consists of positive and negative ions, which are free to move in the solution. When a direct current DC source is connected to the electrodes of the cell, each electrode acquires an electrical charge. Thus, on applying electric potential, the positive ions migrate towards the negative electrode, called cathode, and negative ions move towards the positive electrodes called anode. This movement of ionic charge through the liquid brought by the application of electricity is called electrolytic conduction, and the aperture and the apparatus used is known as electrolytic cell. This is figure 10.1, the migration of ions into electrolytic cell. Positive ion and negative ion, anode, cathode. Oxidation take place, electrons flow, DC source. Reduction take place. When electrolytic conduction occurs, electrochemical reaction take place. The ions in the liquid come in contact with the electrodes at anode. The negative ions gives up electrodes and are therefore oxidized. At cathode, the positive ions pick up electrons and are reduced. Thus, during electrolytic conduction, oxidation takes place at anode and reduction takes place at cathode. The liquid will continue to conduct electricity only as long as oxidation reduction reaction occurring at the electrodes continue. The electrochemical reactions that occur at the electrodes during the electrolytic conduction constitute the phenomena of electrolysis. When a molten salt is electrolyzed, the products are predictable. When an aqueous solution of salt is electrolyzed, hydrogen and oxygen appear at the cathode and anode respectively in certain cases. The products formed from a few electrolytes are shown in Table 10.1a and Table 10.1b. This is Table 10.10a. Products of electrolysis using inert electrodes like platinum or graphite. Electrode, electrolyte, cathode, anode. Electrolyte is PbBr2 molten, cathode PbL, anode Br2G gram. Electrolyte NaCl molten form, cathode NaL, and anode Cl2 in gram. Electrode NaCl in aqueous solution, cathode H2 in gram, and anode Cl2 in gram. Electrolyte CuCl2 in aqueous solution, cathode Cus, and anode Cl2G. Electrolyte CuSO4 in aqueous solution, cathode Cus, and anode O2. Electrolyte KNO3 aqueous solution, cathode H2G, anode O2G. Electrolyte NaOH aqueous solution, cathode H2 and anode O2. Electrolyte H2SO4 aqueous solution, cathode H2 in gram, anode O2 in gram. Table 10.1b. Products of electrolysis when electrodes take part in the reaction. Electrolyte CuSO4 in aqueous solution, copper cathode Cu deposit, copper anode Cus dissolved to form Cu2 plus ions. Electrolyte AgNO3 in aqueous solution and HNO3 in aqueous form. Silver cathode Ag deposit and silver anode Ag into S dissolves to form Ag plus ions.